So, first of all, you guys know about diabetes or diabetes, as you call it in French. You guys know there are two types of diabetes, and there are a lot of people who suffer from diabetes. So, today I'll tell you how industry approaches to diabetes management, because diabetes is one problem that is there in almost all part of the world. There are some statistics that I'll share with you about diabetes. But before that, I just wanted to know you guys know about diabetes. It's a problem in which so what happens in diabetes when you eat food, you eat sugar and sugar converts to glucose and glucose is there in your blood. So your blood needs glucose to create energy and you can work every day, right? So glucose is the energy that you need to function. So for us, glucose is like petrol or gasoline. Now, when you eat sugar or when you eat food, the sugar get converted into glucose. How it gets converted, this is very complicated. We have insulin, and insulin converts sugar into glucose. Now, you can look at the estimate is 425 million people worldwide have diabetes. That is 12% of world health expenditure. And still, we know diabetes is very common, and yet one in every two people remain undiagnosed and untreated. This is the severity of this disease. Many people are diabetic, but they don't know they're diabetic. And even people who are diabetic, the treatment process they're following is not enough to get them cured. Now, there have been a lot of studies around diabetes. There have been a lot of intensive therapies around diabetes, but they're all based on flow, not intelligence. To manage something like diabetes, we don't need a flow. We need intelligence out here. So, and there's a statistics. Okay, I can give you the reference. You can read all of it. And so there's a study which says that people who have diabetes and if they are maintained very well, they'll get cured. But people who are getting treated but not getting treated efficiently, their diabetes will still stay. They won't get treated. The glucose level will still be down. And this chaos is real time. Every country, I'm specifically talking about every country from west to east has this problem. Every healthcare has this problem. They're not able to manage their diabetic population. What do we do about it? This is a chaos, right? Every one person in two goes untreated. This is chaotic. So can we treat it using analysis, data? We just read about our data, right? So turns out there's a lot of data, specifically in the West. In the West and some part East too, there's a lot of health data which is out there. And if we can read that health data, if we can analyze that health data somehow, we can help diabetic people recover. Now, what is health data? Uh, there are a lot of types of health data. There are clinical notes, there are trials, there are records, then there are imaging, your X-rays, then there are sensor data, your glucose level data. And so people saw this, there's a lot of data. People saw, okay, there's a problem, there are diabetic people. Now comes the phase when people try to solve the problem. And we were one of them who were trying to solve this problem. Now, how do we cure diabetes, right? So I explained to you guys that when we have sugar in our blood and that's not getting converted into glucose, you're diabetic, right? So if we can figure out how much sugar is there in your blood and how much we need to convert into glucose, we can cure that person. And this is what we are trying to do. But there are different ways to do it, right? There are different phases to it. Now, uh, to identify a person has a diabetes, there are different ways to identify. And one of them is through your retinal scans. Then there is clinical decision support, in which I'll talk about all of these in little detail in next slides, but I'm just giving a hint about what are the areas in which people are trying to help diabetic people. Then there is predictive population risk stratification, in which we try to see what is the population that is at more risk. Let's say in your city, there'll be a small community which is at a very higher risk of getting diabetic. How can you find it? This is one of the tasks. And finally, there is a self-management tools for patient, right? You are diabetic. If you know about your health, if you know about how much insulin you need to take, if you know about your diabetic condition, you can maintain it. So these are the four trajectory industries working on to help people with their diabetic condition. And trust me, there's a lot of money and what do you say, community support for these tasks. Funding is insane in this department. Now I'll talk about automated retinal screening. So from your retina scan, doctors, they can diagnose specific kind of diabetic conditions. I don't want to go in details. This will be overwhelming. So there are specific conditions in diabetes which are very worse and they're not good. So retina scan, earlier what doctors used to do is you give them a retina scan, they look at it and they'll try to diagnose. And it is a tiring process. Uh, However big retina image I can give it to a doctor, for him, figuring out small patches is very difficult. So people thought, okay, why not use machine learning? What we do is we give an image like this, a bigger one, a more detailed one. This is a drawn image for you to realize how retina images looks like. And then we give the labels, okay, what are the things we're trying to identify, these small things. And we have our machine learning model. We read about object detection, if you remember, object segmentations. This is what is happening. It is trying to figure out what are the part of retina which I have to look at and tell the doctor, okay, this is not good. This guy needs more treatment. And this is the intelligence we get out of our machine learning task.
Mhm.
Clinical decision support. Now, what is clinical decision support? Okay, clinical decision support stays between a doctor, a patient. Clinical decision support helps doctor also and it helps patient also. So what is clinical decision support? Clinical decision support has a lot of factors, right? When I talk from a doctor's perspective, it is okay, what is the health of my patient? What is the condition? What is his temperature? What is his heartbeat rate? These are from a doctor's perspective. From patient's perspective, it is what medications I should take, how much medications I should take, how much insulin I should pump in my blood so that my sugar is getting converted to glucose at an adequate level. Because excess of insulin is also not good. So clinical decision support helps doctor and patient both. And uh, what we have read, analytics helps both of them. Okay, it helps doctor to analyze specific pattern which is coming in his patient profile to identify, okay, this is a specific problem with my patient. And it helps patients also. Patients can identify how much insulin shot should I take today so that my diabetic level stays calm, right? My health stays good. So this is very detailed clinical decision support. If I go inside it, there's a link you can read about it. But it is it, AI and analysis and machine learning can play a very vital role in this. And this is what Edifecs, my company, is very good at. We work with both providers, doctors, we work with patients. And let's say a patient goes to a doctor, and when a doctor writes a patient name in his system, he has his whole history analytically. So our system will tell the doctor, okay, this very patient might get this problem in future. This very patient might get this problem, let's say in 4 months. So you should start preparing for it. So from a doctor's perspective, it's very important. Now coming over to a patient perspective. From a patient perspective, it's important because so we have been taught, right? We go to a doctor and then he'll say, okay, take 2 tabs in the morning, take 2 tabs in the evening, and we do it. He'll say, okay, take it for 5 days. When doctor says take it for 5 days, he is taking an average time, okay? In this much amount of time, this medication will solve your problem. But this is not how the body works, okay? Sometimes access of medication is not good. You'll get good in 3 days and you're taking medication for another 2 days, which is not good for your body. Some medication are fine. They work well with your body, and even if you take it for another 2 to 3 days, they won't affect your body. But some medications, they're not good. For example, insulin. You should not pump more insulin in your blood than it's required. Insulin, I don't want to go in detail, but it's not very good. So clinical decision support is very important. It analyzes a patient's activity, how a patient's blood glucose level is regulated, and then it will advise the patient to take, okay, take only this much amount of insulin today. You don't need more than that. So I guess I made in which we work on is predictive population risk stratification. Okay, so this is self-explanatory. The In all the population, there are specific population who has a very specific genetic structure who are more prone to diabetes. For example, in India, we have a region called Kolkata. Kolkata people or Bengali people, they are very prone to diabetic condition because of their genetic history, how they have lived, how they eat. And predicting which population is at risk is a very interesting task, and you figure out details which you wouldn't have thought about. Like a specific population in California is very prone to this specific disease because of how the weather is, and this kind of information can be used further. Now, this research was very important while dealing with COVID too. And this is one interesting, right? You guys got to know, okay, comorbid are people who are at a greater risk. This was not known out of blue. People actually identified it, that comorbid people and why they have this kind of risk. So basically, this task boiled down to clustering people on their attributes, right? Clustering people on their feature. And we read about clustering, right? Any one of you remember clustering? We had the data points and we tried to figure out what are the different clusters of data. And then we see, okay, this cluster is a problem, right? Here you see three clusters, right? Three or four cluster, and then there are some outliers which are just not in the cluster. So we know this data is not good. But when we look at this cluster and we see, okay, this cluster has a lot of people who are diabetic. And then we analyze people in this cluster and we realize, okay, people in this cluster who don't have diabetic are prone to diabetic. Not today, but in another 5 to 10 years, they'll become diabetic. So predictive population risk stratification is one of the methods which is used by governments, which is used by World Health Organization to figure out what are the population of people who are at a greater risk. And this kind of research continues. And finally, patient self-management tools. Okay, so this is a little tricky. I'll have to explain a little about diabetes. So in diabetes, you check your blood glucose level. Okay, you take your blood and you realize, okay, how much is my glucose level? And this device which we use to monitor our glucose level, it's not very accurate. The reading you get is not very accurate because it's a small device and you cannot do all the scientific thing you do in lab. So since they're not very accurate, machine learning and analysis can help in analyzing those data, and they can tell you, okay, this amount of accuracy is down. We should increase the level by this because this is morning time of day, and your blood sugar will be little lower. It will be detected little lower because of certain conditions of blood. So this is how we use machine learning to determine correct glucose level. We have something called artificial pancreas. So you, instead of your own pancreas, which is not pumping insulin, you put an artificial pancreas, and this will have the insulin. It will keep pumping. So how artificial pancreas will realize when to pump insulin? This is intelligence. We train a model. We tell them, okay, this is how you're going to predict. And finally is activity and dietary tracking system. Harish has a lot of knowledge about dietary tracking system. He worked with one of his students on dietary tracking system. I'll give a little overview about it. So specific to diabetes, when we ask patient to click a picture of their diet, we try to analyze how much sugar content is there in the diet. So if we know his sugar intake, we'll know how much insulin to give and how much glucose will be generated, right? So if we can predict how much sugar he's consuming, we'll know the correct amount of insulin. This graph you see is kind of a time series. What is a time series? So let's say at 2 o'clock his glucose level was X, at 3 o'clock his glucose level was Y. We plotted level versus time. This is called a time series, how his glucose level is fluctuating with time. And analyzing these time series, we get very good insight about how his glucose level drops, how when his sugar consumption is high, when he needs more insulin, when he needs less insulin. So yeah, uh, I've explained all these four specific ways in which machine learning, artificial intelligence, IoTs are helping in diabetic treatment. And these are some of those methods which you have read, and we use them in industry. We use them at a very large level, and they work pretty good. Whatever you have read is very important in industry right now. And so I talked about predictive modeling and risk stratification. It's about clustering and classification algorithm. When I talk about clinical data, it's about natural language processing, which you read in your course. When I talk about time series analysis, how much glucose data is there, and it's just a graph. You look at the graph and you realize, okay, in the morning he has high glucose, in the evening he has low glucose. Most probably he's eating a diet which has very high sugar level in the morning, and some diet which has very low sugar level in the evening. Computer vision, we talked about computer vision, detecting where in the retina there is a problem. And you guys have read about computer vision also. So in food recognition, when I take a picture of a food, I need to tell how much sugar content is there in the food. So I need to identify whether he's eating an apple, an orange, or he's eating chips. If I can identify the content and the amount, I can identify how much sugar, I can approximate how much sugar might be there. So I just wanted to give a glimpse on whatever we have read is important in the industry. This is what is going in the industry.